All right, let's do a walkthrough of practice quiz number 2 for learning target 8 on circles. So to start at the top, golden standard 8.1, area and circumference. So area, here we want to go pi times the radius squared. So what is the radius here? Remember, the radius goes from the center to the outside of the circle. So here the diameter is 4.6, so our radius is 2.3. So therefore, pi times 2.3 squared. Squared means to multiply it by itself. 2.3 times 2.3 is 5.29. So we could write our answer as an exact answer, 5.29 pi. Or we can multiply 5.29 times pi to get an approximate answer of 16.62. And then we shouldn't forget units. So that's area. Circumference now is pi times the diameter. Here, what is the diameter? The diameter is 4.6. So here we can do 4.6 pi. That's an exact answer. If we want an approximate answer, 4.6 times pi would give us about 14.45. So again, area, pi times the radius squared. Circumference, pi times diameter. All right, let's move on down to Golden Standard 8.2 about area of sectors and lengths of arcs. So first question, determine the area of the major sector. Again, you see this word area right there. We're trying to find the area of this sector right here. This mark that is outlined by bold. How much of the circle's area is in that space? A couple different ways to do it. I'm going to show you one right here where we use the central angle, which is 210 degrees right there, out of 360. Why 360? Because this is 210 degrees out of the full 360 degree circle. That's how much of the circle's area is in this portion, this sector, times the area of the whole circle. Pi times the radius, which is 9 squared. Okay. So we're going to keep that fraction, 210 divided by 360. 9 squared, 9 times 9 is 81. So 210 over 360 times 81 pi. Multiply those together, you get 47.25 pi. Or if you're looking for an approximate answer, that's about 148.44. So that is one way on how to find the sector. Okay. The other way would be to think about, well, how could I split this 200 degrees up? Well, here, what goes into 210? Well, we could say, okay, 360 divided by 30 is 12. 210 divided by 30 is 7. So 7 of the 12 slices are in here. So if we find the area of one of the 12 slices and multiply it by 7, we'll be good. So we know the total area is 81. Divide it into 12 slices. That is going to give us 81 divided by 12 is going to give us 6.75 pi in each 30-degree slice. So that's for a 30-degree slice times 7 slices. Should give us the exact same answer, 47.25 pi. Again, same answer, different approach. Next one, find the length of the minor arc. Length means we are looking for this distance from here to here. Length means we're going to use circumference. All right. So what fraction of the circle is in this space? It is 60 degrees out of 360. 160-degree slice out of the whole circle. We're going to multiply that by the circumference. 2 times pi times the radius. So that's 60 divided by 360 times 26 pi. You multiply those together, you're going to get 4.33 pi as an exact answer, or that works out to be 13.61 yards. All right, those are our two golden standards. Let's move on to the backside. All right, so for standard 8.3 here, we're trying to find the area and perimeter of the entire composite shape. What do we have here? We have a triangle and we have a regular pentagon. Now, I know nothing about this pentagon. I could find an interior or central angle, but I don't know any of the lengths. So then I look at the triangle and I say, okay, It's a right triangle, and I know two lengths. I don't know any of the angles because it's not an exterior angle. But if I know two lengths in a right triangle, where can that take me? Well, let's think about this. Here's my triangle. I know this is 8, this is 10. That's x. What tool can I use when I know two sides of a right triangle? I can use Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. So x squared plus 64 equals 100. Take away 64 from both sides. X squared equals 36. Square root, you find that x is 6. Where does that 6 show up on your diagram? It's that length right there. All right, so if we think about this triangle, 6, 8, 10. If you knew your Pythagorean triples, you could get that right away. So here, now we know in this pentagon, all those side lengths are 6. Well, with that, can we find the area of that pentagon? Absolutely. All right, so let's find the area of the pentagon. So 360 divided by 5 is 72 degrees. We're going to use the same process we used in that previous golden standard. Make the isosceles triangle. 72. We know the side length is 6. We are looking for, now it's 3 because it's half. We're looking for this height because we want to find the area. So I see opposite and adjacent to this 36-degree angle. Why 36? Because it's half of 72. Remember, we're only taking that half. So then we're going to use tangent, opposite and adjacent. Tangent of 36 equals opposite 3 over adjacent x. Multiply by x because it's on the bottom. So x times tangent of 36 equals 3. Get x by itself. Undo times tan of 36 by dividing by tan of 36. So x equals 3 divided by the tan of 36. So x equals 3 divided by tan of 36 is 4.13. Okay, so where does that take me now? This is 4.13, which means the area of this triangle, base is 6, height is 4.13 divided by 2, which works out to be 12.39. There are 5 of those triangles inside the pentagon, so my total pentagon area is 61.95. Let's just mark that right here. So that's pentagon area. Okay. Now, is that my final answer? No, I want the area of everything. So I know the pentagon is 61.95. What's the area of this triangle? Well, the area of this triangle, base is 8, height is 6, divided by 2, 48 divided by 2 is 24. So total area is the pentagon area plus this triangle area from right here. So my total area is 85.95 square inches. Now I'm not done yet. I also need to find the perimeter. Now this one's a little tricky. Be careful here. It's not just the golden standard. All right, the perimeter here is the around the outside of the large shape, the composite shape. Notice what's not included. It's not just 5 times 6. One of the 6's is not included. So the perimeter is what? There's 4 6's. 1, 2, 3, 4, plus 8, right there, plus 10. Go back to last fall when we did this. 24 plus 18 is 42 inches. All right, total area, total perimeter. Whew, okay, let's get to 8.4, problem solving. All right, with circles. Now, how do we do this one? All right, so for this one, determine the area of the shaded region. Okay, so I see the shaded region appears to be, it's a square with like a semicircle here, with a third of the semicircle taken out. Okay, now I see the square, the sides are 10, which means this side's 10, which means this side is 10. Now, if this is a semicircle, and those are both 60 degrees, that means this angle is 60 degrees. That means this is split in half. This side is 5. That's 5 right there. That might be helpful for telling us the radius of that space, that circle that's right there. Okay, so it looks like we got to take the area of the square, subtract the semicircle, but add back this sector right here. Okay? So I like to always clarify myself what I'm trying to do. So the shaded area is the square minus the semicircle, but add back that sector. Essentially, it's the square minus that shape, but add back that sector in the middle. Okay? Now I know what I'm trying to do. So now I just need to find the area of each thing. Okay, so first step, the square area, 10 times 10, so that equals 100. The semicircle area is what? Well, it's half, because it's half the circle, times pi times the radius squared. So that works out to be 12.5 pi, which is the same as 39.27. Okay? Now what is that sector area? Well, that sector right there is like a third of that semicircle. Okay? So it's 1/3 of that 39.27. All right, see how that right there is like 1/3 of this semicircle? So you divide that by 3. Turns out the sector area is 13.09. So then my total shaded area is what? 100 minus 39.27 plus that sector. So my final shaded area is 73.83 square meters. All right, good luck on your LTA quiz.